I equals 1 to n, f of x I star delta x will, if f is continuous, it seems that when the n goes to infinity, this limit will exist and equal to area. By using that symbol, the limit of this finite sum so this is the sum, this is the function integrated, and the dx stands for very small. We can use this to find the area of this region, bounded or enclosed by this curve and this 3 straight lines. 所以我们要算这个曲线跟这3条直线所围出来的面积区域的面积的时候，我们可以用相乘相加再取极限啊。以前虽然导数或斜率是相减相除的写极限，现在就把以前的加法跟乘法再加个极限就好了，就是积分。Okay, here we will give a precise definition of definite integral. Suppose f is defined on a bounded closed interval AB. Then we partition this interval into 2 equal sides by consider delta x equals, is defined to be b minus a over n, where n is a positive number. For example, n equals 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In this case, delta x equals b minus a over 12. Okay, then we define some numbers xi is defined to be from a plus I times delta x. Usually we use the lower case of I, j, k to indicate integers. 好，我们定义一些数字或分点啊。x0 means start from this point and then move to the right by 0 step. x1 means 1 step. x2 means 2 steps. x1, x2, x3. b or xn means from a move n delta x. Okay, so here you will see x a equals x0 and less than x1, less than x2, and when I equals n times delta x, a and n are cancelled, a and a are also cancelled, this is b. Okay, so we call this as a partition. Also, we choose some sample points. The ith sample points from the ith interval. Okay, so x1 star x2 star, x3 star, and so on. Arbitrary. Okay, so this part is about this interval. 这一部分跟区间有关。Then we form this finite sum, sigma equals 1 to n to immute that finite sum. So if this is velocity and this is time, then this will be a displacement. If n goes to infinity, this limit exists. Then we define this symbol to be the limit of this finite sum. No matter what sample points are chosen. Okay. For all possible choices of sample points, if n goes to infinity, those values goes to the same number. If this limit exists, then we say f is integrable on or over on AB. And the limit is called the definite integral of the function f from the number a to the number b. Okay, so this is the definition of integration, definite integral. In the future, you will encounter some other kinds of integrals. For example, indefinite integral. If a function of two variables, we will have double integral, iterated integral, three variables, triple integral, multiple integral. Multiple integral means if the integrand, the function, integrated function is not the function of one variable, maybe of two or three or more variables, then we call this different integral multiple integral. And also we have line integral, surface integral, and so on. Okay.
But why n is approaching infinity like something?
Oh, so if a big if this limit exists, of course, if f is continuous, as I told you, this limit will exist. Why? Because if here we consider continuous by the, okay, because I want if f is continuous, suppose then f has maximum value and the minimum value by extreme value theorem. Okay, so f is continuous on a, b, x must be a continuous on this small interval. And here we have a maximum of f and the minimum of f. F has a minimum value at here and the maximum value here. So the first term will between okay. Suppose maximum of f on this interval at x equals d1. Okay, for simplicity, we call this m1. The minimum is lowercase m1. Then multiply delta x simultaneously. This means this area between the area of this rectangle and the area of this rectangle, because this is the red area, minimum, and this is the area of this one. M is maximum. Is the maximum of this function on this interval, but this is any simple points, any. So this value between these two values, okay. This can be similarly for each I. We can consider this to each subinterval. On each subinterval, the minimum will be here. Okay.
As long as it's continuous, it's
Oh yes, if continuous and interval, yes, you're right. So usually you're hard to believe for any possible choice of sample points. How can it converge to the same number because of the continuity? If n goes to infinity, then delta x will be very small. By the continuity, the minimum and the maximum are almost the same. No matter what sample points are chosen, they always goes to the same number. So the continuity is very good property for given function. 所以他刚好问到说，这怎么知道那个会存在？我说哦，在连续的条件下，它一定会存在的。因为我们在每个区间里面取一个样本点，样本点的值呢，不会超过在这个小的区间的最大值跟最小值。这最大值跟最小值永远存在。这个因为连续函数，在一个必须上连续的函数，永远有最大值跟最小值，这就是极值定理。好，只要 n 足够大，你会发现这两个端点呢，几乎是一样的，以至于这发生最大值跟最小的这两个点几乎是重叠的，因此它们两个值根据连续性几乎是一样的，所以变成跑到同一个值去了。So, this is the reason why the continuous of closed bounded interval is so important. Not only give us extreme value theorem, if differentiability is involved, then, Fermat theorem.
And these squares are different integrals.
You mean the square of what? Okay. Oh, yes, for this one, the maximum will be here. And the minimum will be the lowest part here. And the middle term is the white. It's this area. Of course, this area between the large one and the small one. If n goes to infinity, then these 2 points will almost the same. And the CI and the DI are almost the same by the continuity. This one, and this one are the same. Almost the same. I mean, this, and then these 3 numbers almost the same. So you can choose any sample points. Choose any point from each subinterval. We'll go to the same value. What value? The area of the value is, yes, this one. Okay, finally, this so integration also comes from 2 motivations. One is from physics displacement. Another is